We've spent the last several lessons talking about our trig functions, sine, cosine, and tangent. Today we want to spend some time talking about inverse trig functions and how we can use those to solve both problems and trig equations. Some of this is going to feel a little bit familiar, and then we'll get into some new things. So what you're already familiar with is a problem like number 1. We have a photographer standing 60 feet from the White House, which is 70 feet tall, and it photographs a bird on the roof. So I'm just going to draw that real quick. Okay, so there's the White House, and we're 60 feet away. So 70 feet tall, 60 feet away. And we want to find the angle of elevation from the photographer's eye to the bird up there, right there. So we are looking for this angle. So this is just a SOHCAHTOA problem. We have an opposite and adjacent side, so we're going to use tangent. So the tangent of our angle, I'm just going to call it x, is opposite over adjacent. And we want to solve this for x. So what we're going to do is, the way we undo tangent is we take the inverse tangent of both sides. So we take the inverse tangent of this and the inverse tangent of that, and tangent and inverse tangent cancel out. And so then in your calculator, you're going to do the inverse tangent of 70 divided by 60, and I need a calculator to do that. Oops. Inverse tangent is located above your tangent, so you'll hit second tangent, and we get about 49 degrees here. So you should be familiar with that button from geometry. Okay, so the inverse of sine is inverse sine. It looks like sine to the -1, but it's not. We read this as inverse sine. Another way we write that is arc sine. And you're going to be seeing that more and more as we get into trig and calculus. Arc sine is probably a little bit more common than inverse sine. So either one is fine for now, but I want you to start getting used to that. They mean the same thing. Cosine, the inverse of cosine is, of course, inverse cosine or arc cosine, and then we have inverse tangent and arc tangent. We do have inverses of secant, cosecant, and cotangent. We're not going to work with anything on those this year, but they do exist, and we'll see them next year. So when we're using inverse trig functions, we are looking for angle measures. So now I want to kind of talk through inverses a little bit before we get back into inverse trig functions. So remember how we find inverses. If we're looking for the inverse of y equals x squared, remember, this is way back. To find inverses, we switch the x and y. So the inverse is x equals y squared, which if you want to solve that, you're going to take the square root of both sides. So we get y equals, and since we introduced the square root, it's y equals plus or minus the square root of x. We want to know, well, what do these graphs look like? All right, well, let's take a look. Pop over to Desmos. Okay, so we know that y equals x squared is a parabola, and then y equals plus or minus the square root of x. You probably remember our square root function looks like this. Since we have the plus or minus, we get both the top and bottom of that. And what do we notice about the graphs? Well, hopefully you remember that inverses reflect. They reflect across the line y equals x. And we can see that. Fantastic reflection here. Now, the problem with this is if we look at the inverse, okay, it's not a function. Okay, remember, to be a function, you have to pass the vertical line test. And if you draw a vertical line here, you hit it twice. This is not a function. So what we do to make it a function is we say, well, let's ditch the bottom half of it. And if we do that, it's no longer a reflection. So let's restrict the domain. Instead of keeping that full parabola, let's just keep that part. And now we have both of them that are functions. So what this means is, if you want your inverse to pass the vertical line test, that means your original function needs to pass what we call the horizontal line test. Okay, so any horizontal line can't hit it twice. if it does hit it twice, we have to restrict it so that this passes the horizontal line test, and that means its inverse will pass the vertical line test. Okay, let's think about what this means for sine. Let's get rid of that. So this is the sine function. If we reflect this across the axis, instead of being a wave across the x-axis, it's going to be a wave up the y-axis. Okay, so kind of think about it going up. Now, if we do the inverse of sine, it is not going to be a function because it does not pass the horizontal line test. Like, just think about drawing a horizontal line here. See how many times it hits? No good. Okay, so this does not pass the horizontal line test. So what we want to do is we want to restrict this function to the biggest section that does pass the horizontal line test. And our biggest section that does pass the horizontal line test is going to be from here to here. Okay, so that portion of it. Okay, so again, we're taking that sine function. There's the whole thing. And I just want to see, I want to restrict it to a part that'll pass the horizontal line test. Okay, when I do that, I'll be able to take the inverse of it. And so if you do want to graph arcsine, Desmos will do it for you. It'll reflect it across there, but it will only do that little piece of it. Now, we do not need to worry about graphing arcsine. It's just not really something that we worry about. What we are going to think about is these restrictions. So we want to restrict sine to this little section. Let me change the increments here so you can see them. Go by pi. There we go. Okay. So for sine, we are just looking from negative pi over 2 to pi over 2. All right, so let's think about cosine. Here's my cosine graph. Again, I want to think about the biggest section that will pass a horizontal line test. And the biggest section that will do that will be from here to here. Okay, so when we restrict cosine, we are going to go from 0 to pi. That's a little bit different, and we'll just take that segment of it. Okay. And then for tangent, remember our tangent function looks like seaweed. This is not going to pass the horizontal line test unless I restrict to just one seaweed. Okay. If we just look at one seaweed and restrict from negative pi over 2 to pi over 2, or from negative 90 degrees to 90 degrees, now we pass the horizontal line test, so we can take the inverse of it. So going back to our notes, this gives us all the information, this little table. Okay, so if we are talking about arcsine, the way we write that is arcsine or inverse sine, we have to restrict from negative 90 degrees to 90 degrees, or negative pi over 2 to pi over 2. Okay, and it's so that it passes the horizontal line test. Sorry about that. Cosine, we restrict from 0 to 180, or 0 to pi. And tangent, we restrict from negative 90 to 90. So what this means by quadrant. If we have arcsine only happens from negative 90 degrees, which is down here, to 90 degrees, which is here. Okay, so arcsine is only happening in these two quadrants. If the arcsine is positive, it's up here, and if the arcsine is negative, it's down here. Okay. Tangent works the same way, from negative 90 to 90. So if the tangent is positive, anytime you're positive, you're in the first quadrant. They're all here. And then if arctangent is negative, you're down here. All right, now cosine is different. Arccosine happens from 0 to 180, so that's here, these two quadrants. So if arccosine is positive, you're in the first quadrant. If arccosine is negative, you're over here. And we are never in the third quadrant when we're dealing with inverse. Okay, so this is our little acronym we're going to think about, CAST. Okay, and this is going to help us remember what quadrant we're in. We're going to be drawing triangles. So anytime you have a positive number, you're going to draw your triangle. Oop, I didn't mean to erase that. You're going to draw your triangle in the first quadrant. If you're doing arcsine or arctangent of a negative, you're going to draw on the fourth quadrant. And if you're doing arccosine of a negative, you're going to draw on the second quadrant. We will start working through examples of these in the next video.